Welcome back. We will be looking at the properties of the cross product now. So let's say A, B, C are vectors in the 3 space. Then the property number 1 of the cross product is that A cross B is equal to the negative of B cross A. The cross product is not associative, that is A cross B cross C is not the same as A cross B cross C. So on the left hand side you are taking the cross product of A and B first, and then whatever vector you get out of that you take the cross product with C. On the right hand side you are taking the cross product of B and C first, and then whatever vector you get there you take the cross product with A. So it's not, cross product is not associative. It means that this equation doesn't hold. The cross product distributes over addition, so A cross B plus C is the same as A cross B plus A cross C, and also B plus C cross A would be the same as B cross A plus C cross A. Property number 3 is A dot product. So this is the dot product. A dot product with B cross C is the same as A cross B dot product with C. For any scalar C, C times A cross product with B is the same as A cross CB, which is also the same as C times A cross B. So here when we write C, that's the scalar product. So here also CB, here we're doing a scalar product, and then here you're calculating A cross B first and then multiplying by the scalar C. Property number 5 is that A cross B parenthesis cross C is the same as A dot C multiplied by the vector B minus B dot C multiplied by the vector A. So here these are dot products. Remember, A dot C would be a scalar, which is what and then you're multiplying the scalar with the vector B. B dot C is a scalar, you're multiplying that scalar with A. Property number, so let me just say that all these properties can easily be proven by just computing each side by using the components of A, B, and C. So the property number 6 says A cross B is perpendicular to both A and B. Okay, so in order to so I'm going to give you a proof of the property number 6. To show that A cross B is perpendicular to both A and B, what I have to do is I have to take the dot product of A with A cross B and show that it's 0. So let's take the dot product of A with A cross B. Well, A is A1, A2, A3, dot product with A cross B, and the definition of A cross B tells us that the components of A cross B are given by A2, B3 minus A3, B2, A3, B1 minus A1, B3, and A1, B2 minus A2, B1. So now we take the cross dot product here. So A1 will be multiplied by the first component here, A2 will be multiplied by the second component here, A3 will be multiplied by the third component here. So that's what we have. So now we multiply out completely. So A1, A2, B3 minus A1, A3, B2, A2, A3, B1, A2, A1, B3, A3, A1, B2 minus A3, A2, B1. So after we write them, we see that all of them cancels out, so we get 0. So as a result, we can say that A cross B is perpendicular to A. Exactly the same way, we can, instead of taking b dot a cross b, we can also take, instead of taking a dot b a cross b, we can also take b dot a cross b, and we just do the same calculation, and we can easily see also that b dot a cross b is 0, which means that a cross b is perpendicular to b as well. So what we know is that that given the vectors a and b in the 3 space, the vector a cross b is going to be perpendicular to both a and b, which means that the vector a cross b is perpendicular to the plane spanned by a and b. And b cross a just has the opposite direction as b cross a has the opposite direction of a cross b. Now, so if we know the okay, so how do I know, okay, so what's the direction of a cross b compared to a and b? Well, we have to apply the right-hand rule to figure out the direction for a cross b. So to find the direction of a cross b, we put our right-hand wrist at the tail here, common tail of a and b, and then our fingers should be extended along a, and then we should curl our fingers toward b. Then our thumb will show us the direction of a cross b. Okay, so the direction for a cross b can be found by using the right-hand rule. Okay, so that was property number 6, that a cross b is perpendicular to both a and b. And then we also know how to find the direction of a cross b by using the right-hand rule. Here is property number 7. The property number 7 says that the length of a cross b squared is the same as the length of a squared times the length of b squared minus a dot b squared. How do I prove something like 7? Well, again, you just denote the components of a and b, let's say by a1, a2, a3, and b1, b2, b3, and then just compute each side in terms of the components and see that they are the same. Okay, so I won't give you a proof of property number 7. Now, the property number 8 is going to be very important for us. It says that the length of a cross b is equal to the length of a times the length of b times sine theta. And so this is a very important property. Let's look at a proof of 8 where we're going to use number 7. So using number 7, the length of a cross b squared is length of a squared times length of b squared minus a dot b squared. Now a dot b, we know that is given by length of a, length of b times cosine theta, where theta is the angle between a and b. And the angle theta is between 0 and 180. So here then we get length of a squared, length of b squared minus length of a squared, length of b squared times cosine squared of theta. You see that we can factor out length of a squared times length of b squared. If we do that, we get 1 minus cosine squared of theta. But that's the same as 1 minus cosine squared. Theta is the same as sine squared of theta. So what we are getting then is that the length of a cross b squared is equal to length of a squared, length of b squared times sine squared of theta. And then if we take the square root, then we see that the length of a cross b would be equal to length of a times length of b times sine theta. Okay, so I'm going to stop here. So these are the 8 properties of the cross product. In the next video, we will see how property number 8 gives us a nice nice geometric interpretation of the cross product.